All right, I'll go through the exponential first, and then we will do the logarithmic equations. Basically, with exponential, there are two types. Okay, there are the type with an exponential where you have bases that match, and then you have the second one where you have bases that do not match. Okay, so whenever we do the first one, whenever you have two numbers that have exponential functions or exponential equations that are equal to one another. Okay, with all of these, everything's going to be equal because it's an equation, so you're going to have to solve for x or a or whatever your variable is. The first one, you are going to have bases that are going to be the same. Okay, 2, 5, 7, whatever. Okay, or you have variables or you have numbers that can have the same base. So like on your example, it says 2 to the x power is equal to 2 to the 16th power. So your exponents are going to be set equal to one another. So in your first example, if you have 2 to the 4x power, and then it's equal to 32 to the x minus 1 power. Okay? Can you make, the 2 is basically as low as it's going to go. Can you make the... So on like the 2 to the 4x power side, on the left side, we can't do anything with that. But we can actually change what the 32 is because I can change 32 to where they have the same base. So how can I rewrite 32 that instead of it being 32, but it has a base of 2? 2 to what power? 2 to the 5th power. So the left side is still going to be 2 to the 4x power. The 32 is going to turn into 2 to the 5, or 2 to the 5th power, excuse me, and then x minus 1. Okay, all I did was change the 32 to 2 to the 5th, and then that 5 is just going to get multiplied by x minus 1. Once you get bases that are the same, then really, I don't care about those anymore. Okay, all I'm going to do from here is just set 4x equal to 5 times x minus 1, and I'm going to solve. Okay, so I'll have 4x equals 5x minus 5, negative 1x on the left side, negative 5 on the right, so x is equal to 5. Same way on 2, okay? It just depends on, I may have to change one, I may have to change both of them, okay? This one I could actually do two different ways. I could change them to where they both have a base of 3 and still solve it and get the same answer. Okay? Now, realistically, I'm going to change the right side and not the left, and I'm going to leave it as 9 to the 2x power. I'm going to leave it as 9 to the 2x power, and I'm going to change the 81 to 9 to the 2nd power and go 3x minus 2. Now, like I said, you could have done almost like a second problem and changed the 9 to 3 squared and multiply it with 2x and do the same thing with the 81 and have 3 to the 4th. And multiply that by 3x minus 2. Okay, and gotten 4x equal to 12x minus 8. We're still going to get the same answer. Okay, the one on the left and the one on the right, I'm still going to get 2x equal to 6x minus 4. Negative 4x equal to negative 4, and x is equal to 1. It would work out the same way on the right side. If I would subtract, I would have a negative 8x equal to negative 8. I would still get x equal to 1. Okay. So on this one, there's really no, on the second example, there's really no right way of doing it. Okay, as long as you either stick with the two bases as being 9 or the two bases as being 3. Okay, it's really up to you. Now, whenever they're different, so your second type is you're still solving, that doesn't change. is when you have two sides of your equation to where you either may have one variable, like on example 3, where you have 4 to the x power is equal to 15. Okay? You can't get 4 and 15 to have the same base. Okay? Even on the one on the right, on example 4, I've still got to move everything to where I have just an exponential or an exponent and a power on one side and then whatever else on the other side. Okay? I can't have any adding or subtracting, multiplying or dividing. I need to get rid of to where I just have an exponential on one side and then maybe an exponential on the right, or most likely it's just going to be another value. So whenever I do this, I'm just going to turn it into a logarithm, and I'm going to have, so the left side, if I turn this into a logarithm, the 4 stays, so I'm going to have log base 4. If I turn an exponential into a log, that means the 15 is going to come to the other side, and the x is going to go to the opposite side. Now, depending on what you have, if as far as like a calculator, if you have like the newer one with the 84, to where you can basically just type it straight in as log base 4 of 15. You may, however, if you don't, if you just have a graphing calculator or like a TI-83, or you have a scientific calculator, then you're going to have to go log of 15 divided by log of 4 and do change of base there. Okay. If you have to do change of base, it's going to be all right. You'll end up getting log of 15 divided by log of 4 is about 1.95. Okay. So about 1.95. Again, you may be able to, depending on what kind of calculator you have, type that straight in. Okay. If you have an 83 or later, or earlier, I guess would be the right way of saying that, or you're using a scientific calculator, you're going to need to do change of base here to get your final answer. Okay. Most of the type 2 are not going to end up being a nice, neat number. Okay, I'll just go ahead and tell you that right now. Now, on 4, like I said earlier, before you do anything, you have to move this 3 over to the other side. I understand that 5 and 25 can make the same base. But the problem is you have that plus 3 on the left side that you have to move everything else over to the other side. So in doing that, I'm going to have 5 to the x plus 2 power equal to 22. So then from there, I end up doing log base 5 of 22. Okay, 22 comes over. X plus 2 goes to the other side. Now, if I would cut you loose here, I would probably have about half of you do one thing and half of you do the other. Okay? Half of you would move the 2 over right now immediately and do log base 5 of 20. Okay? That's not what we want to do here. We want to find the log first, because if I would move the 2 over, remember that whenever we have like log base b of x minus h plus k, okay, whenever we graphed it, could we combine the h and the k? No. So if we would move that 2 over, we can't combine the 22 and the 2. Okay, it doesn't work that way. So these two parts, like the 22 and the 2, are two different sections or two different portions of my graph. They're apples and oranges. We can't combine them. So what I've got to do here then is I need to do change of base, and it's really up to you as far as how, obviously, with whatever kind of calculator you're dealing with or whatever you're having to do. So I'm going to have log of 22 divided by log of 5 is equal to x plus 2. Now, what I would tell you to do is do the change of base first, if that's what you have to do. So do log of 22 divided by log of 5, and end up getting, it's about 1.9205, so on and so forth. Okay? Leave that value in your calculator and then subtract the 2. Then add the 5 or whatever you have to do to the other side. If you have to multiply it, multiply. If you have to divide something, divide something. Okay? I wouldn't round anything until the very end. Just like we've talked about whenever we did exponentials, whenever we did the interest problems, stuff like that. Don't leave that value of 1.92, so on and so forth, that you got right here, and then worry about subtracting the 2. Okay, so it's like you're doing this in 2 parts, essentially, of like log of 22 divided by log of 5, and then subtracting the 2. I'm okay with you doing that, just don't subtract the 2 from the 22 or the 5. Okay, whenever I do that, then I'm going to get about negative 0.079 or 0.008. And it's understandable as far as if you would have subtracted the 2 from the 22. Then on the back side, okay, if you have anything that has a base of e, it's really up to you as far as how you want to do this. Again, I still need to get the exponent by itself. So if I have 40 times e to the 0.6x power is equal to 240, I have to get my exponential by itself first. So in doing that, what do I need to do first if I'm going to get the exponential by itself? How am I going to get rid of that 40? Divide by 40. So I divide by 40, I get e to the 0.6x power equal to 6. Now, remember, e is just a number. Okay? But I need to still turn this in. I can't make 6 into a base of e. So I need to turn this into a logarithm. Now, this next step and the step after it is really up to you as far as if you can remember that if you have a base of e, that it's going to turn into a natural log. Most students, to be perfectly honest with you, especially early, will turn this into log base e of 6 equal to 0.6x. Now, the problem here is I don't have a log e button. I guess I do. Okay, it's called the natural log. Okay. But this part right here, or this next step, is just going to end up being the natural log of 6 equal to 0.6x. Again, this right here is just a number. The natural log of 6 is some number. It's some random long decimal that's never going to stop. Okay? But it's just a number. So treat it that way. So if I have the natural log of 6, what am I going to do to get x by itself? What do I need to do? Yeah, divide by 0.6. Okay? It's going to be the same thing. Like if it ever asks for like the exact answer, you know what you're going to put? The natural log of 6 divided by 0.6. This is the exact answer. If that's all it asks for, that's all it asks for. Now, if it asks for everything in terms of a decimal, then we're going to put 2.99. So if you have a natural log and it asks for the exact answer and you put the natural log of 6 divided by 0.6, you're good to go. You can stop right there. Now, if it asks for the decimal, then give the decimal. It's not going to change if I have e to the negative x power equal to 9. I'm still going to, and I will still have students that will change this to log base e of 9 equal to negative x. That's completely all right. Now, remember, log base e is just the natural log of 9. Again, if I ask for the exact answer, what's going to be the exact answer? Yeah, I'm just going to divide by negative 1, right? Or multiply by negative 1, either way. So the natural log, negative natural log of 9 is my exact answer. If it asks for the exact answer, but in all reality, if it asks for like 2.1, I don't remember what it is. Negative 2.2. Okay, if it asks for the decimal, both answers are right. Okay, one's exact, one's abbreviated, essentially. Now, these types of problems, as far as your 6.6 assignment, okay, or the solving exponentials and logs, that's going to be your first 7 questions. Okay, your first 7 are going to deal all with exponentials.